2.2 is multiplication. So I don't know that we're going to see it in much different light than what we saw in 2.1, but well, I guess we'll see some multiplication of some bigger numbers. But again, there is a very important, it's very important to have at least the first 12 multiplication facts memorized. And 0 should come pretty easy because anything multiplied by 0 is 0. Multiplication by 1 should come pretty easy because anything multiplied by 1 is itself. And then you could say, well, okay, anything multiplied by 2 is even, or multiplication by tens is just tacking a 0 on to whatever number you're multiplying it by, and that's nice. But the rest of it, it's the stuff in this area right here, which I think is very, very crucial to have memorized. It's at the very least, it will speed things up for us, making things extraordinarily convenient. So multiply using the times table above. Whether you use the times table or not is up to you. It would be very nice if you had this stuff memorized. So again, just memorization, meaning if I said 8 times 4 is what, you'd know right away that it's 32. But if you need to use the table, it's up to you. And again, for me, the first number is just going to come from the column, and then the second value is going to come from the row here at the top. All right, so I'd say, okay, 8, that's 8 right here, and then a 4, 8 groups of 4. So I would follow these until they meet. So the 8 and the 4 meet here, which is, looks like that's a 32 right there. So the product of 8 and 4 is 32. Or this next one, 9 groups of 2, 9 times 2, the product will be, again, we're going to look to our table for this. So I'd have, find 9 in the column and 2 in the row. I'm trying to color code these as much as I can. So 9 goes here, and then the 2 would go down to the same number. 18 looks like that is our product. So same thing with the next one. We got 4 groups of 5. So I find 4. All right, so yeah, I got 4 in the column here, and then 5 in the row. And again, if you have those reversed, that's okay. And then I follow these until they meet, right? So this one looks like this product will be 20. There we go. And same with the 6 and 7. So I start with the 6 in the column, 7 in the row, and I just see where these two lines come together, which appears to be 42. So the product of 6 and 7 is 42, or 6 times 7 is 42, or 6 groups of 7 is 42. However you like it, right? And in addition to that, maybe it'd be helpful to see this fact family stuff more directly. So if we looked at 9 times 2, the fact family, which would say that if you took the product, which is 18, it will equal, I'm sorry, not equal. I would take the product, which is 18, and then I would divide it by either one of the factors. So I could say 9, and then it would equal 2. Or if I wanted to take the product, 18, and divide it by the other factor, which is 2, that would equal 9. And that gives us a fact family like that. And yes, I'm pointing this out because we will see a little bit of division in this section. So there we go, fact family. This one would be between 3 and 4, right? You got the two factors, 3 and 4, and the product is 12. So you take the product, 12, and divide it by either one of the factors to get the other factor. Now, using the table, I think, is a little bit more easy when we consider this. But again, if you have the fact families or the first 12 multiplication facts memorized, then you're in pretty good shape, right? So let's see, what do we got? Let's start with 21 divided by 3, right? So 21, that would be the product, which means I'd be looking in one of the white boxes. And again, if you have memorized, that'd be much better. And I need it to have a relationship with 3, right? So I'd say, oh, there's 21. And I can see it does have a relationship with 3. And it doesn't matter if it's in the row or the column because the other relationship is going to be this quotient, which in this case is 7. So 21 divided by 3 is 7. Or if you wanted to say the other way around, just with the fact families, 21 divided by 7 would be 3 as well. I know it didn't ask for that, but it does. Or in this next example, I got 2 divided by 2. Now again, 2 would be the product. And so I'm looking in one of the white boxes, and we shouldn't see too many 2s. I'm going to look at this one right here. And I need it to have a relationship with 2 in either the row or the column. And yeah, I see it has a relationship with 2 right there in the top row, which means the other relationship is going to be, which is in the column. That will be our quotient, and that is 1. So I'm going to give you, take 1 minute and just see if you can do these next two. We got 24 divided by 8 and also 54 divided by 9. Whether you use the table or the fact families is really up to you. But try that out, and then we'll come back in a minute and go over these together. So 24 divided by 8. Now, you could say you're going to use the fact family, right? And I haven't really shown that explicitly, and that's okay. We're going to do it now. All right, now 24 would be the product. So you'd have to say you're going to take 8 and multiply it by something to get 24. Now, what this does, if you do change it into the multiplication using this fact family stuff, then what you can do is you can find 8 either in the row or the column. I'm going to use the row, I guess, just because I'm already there. And you're just going to follow the 8 until you get to the 24, right? Okay, so that would be the product. The product of 8 and what? Well, that's where you got to follow up the other way, in which case for me is up to the row. And that shows that it would be 8 times 3, right? Which means that 24 divided by 8 is 3. That would be the final answer on this one. So we could do the same thing with this next one. You could say, okay, 54, that's the product. If I change it to multiplication, it would be the product between 9 and some value like this. So that means I would be multiplying 9 by something, so I'd have to find 9 in the table. So I would find it here, and then I would follow it down until I get or see 54, because that's the product right here. And then I'd have to follow to the other line to find what it's multiplied by, and that's 6. Which means that 54 divided by 9 is 6. Now, the last thing I'm going to point out about these two problems is we see 2 divided by 2 is 1. That's an important property which will be coming. Anything divided by itself is 1. That will be very crucial once you get into algebra stuff. So multiplying by stacking. If you multiply and have more than 10 of a certain place value, it must be carried, added. And yeah, this is important. When we carry in multiplication, we're not multiplying by that value that's being carried. It's just being added, which we're going to show with some of these examples that we're going to be seeing, all right? So we apply the second factor by place value to the first factor by place value. So multiplication still takes place by place value. What this really is a problem like this one is the top number, the first factor, which in this case is 123. It's really being multiplied by 2 different values. And this is kind of where expanded form of numbers comes into play, right? You'd say, well, it's 123 multiplied by the ones place value, which is 5, right? I put a 4 there. I apologize. That's not supposed to be a 4. Whoa, that was weird. That's supposed to be 3. 123 times 5. That's from the ones place value, but when I multiply by 4 right here in the tens place value, it really is 410. So what you would end up looking at is 123 times 40. And then whatever you get out of those two products, that's what you would be adding together. All right, and it could include some carrying. But of course, there's short ways to show this, and there's long ways to show it. This would be kind of the long way to do it. But the nice thing is if we focus on multiplying this way, really all we're doing is multiplying by one number at a time, and then maybe adding some of the carrying that's taking place. But that also means that having at least the basic multiplication facts down from 0 to 12 is pretty crucial, right? Because we're just by separating these into place values, it allows us to multiply by one digit at a time. So 423 times 2, that's our top one here. I would rearrange this using stacking as 423 times 2. All right, so it's multiplication. Now what I do is I multiply. You should start with the ones place value first, okay? And in fact, some people don't like to show the arrow that way. It's like, hey, you're going to multiply 2 times 3 first. And if we got that memorized, 2 times 3 is 6. If you don't memorize it, then you can count by 2s, 2, 4, 6. That would work. So that's the ones place value. Now in the tens place value, we didn't see any carrying in this one. That was fine from the ones. So now I go to the tens. This really is the multiplication of 2 and 20 right here. Now, two groups of 20, that may be harder to understand than if I just said, well, 2 times 2, right? And if I know I'm in that place value, then the product between those is going to stay in that place value. So 2 times 2 is 4, which also means from this product, 2 times 2 is 4, since this 2 was in the tens place value, 2 times 20 would have been 40. But I still have the 6 that came from the 3 times 2 right there. So then I would multiply the 2 times, again, this would be really 2 times 400. But since it's multiplying by place value, I don't need to worry about the hundreds because I have numbers to fill in the ones and tens place value. So I'm really just looking at 2 times 4. 2 groups of 4 is 8. And that would be the product in the hundreds place value. So that multiplies all three of those numbers. We didn't see any carrying in that case, and that's okay. We'll see plenty of carrying as we do these. But the final product of 423 and 2 is 846. So doing this next problem, this is 14 times 5. That's good. But again, I still start in the ones place value, right? So I'd say, okay, 5 times 4, 5 groups of 4 is 20. Now, the problem with this is 20 doesn't leave me with any numbers in the ones place value other than 0. And I'm not really going to be multiplying with the 2, right? It's just going to be added on to whatever the result is of 1 and 5. And this multiplication, so I'm looking at that product. So what we do is we carry the 2 into the tens place value, but it's not being multiplied. It's going to be added to whatever this result is. Now, 1 times 5 is 5, right? In fact, let me set this up just a little bit different. So the 2 up there, the 2 that we carried, right, that came from the 4 times 5. That's 20. And I just did 5 times 1, but it was really 5 times 10, which is 50. So we take these two and we add them and see where the carrying comes into play. Like if you wanted to shortcut that thing and put the 2 above it, you can do 5 times 1. As long as you can do that in your head, that's fine. This may be a little bit more organized for you if you want to do it this way. But then it's now become a simple addition problem. 0 plus 0 is 0, and 2 plus 5 is 7. So our final product of 14 and 5 is 70. So now we got a 3-digit number times 9. That's fine. We can do that. Stack it. 651 times 9 like this. So I'm gonna write each of these out separately, right? Because we can. And then you can make the determination on if you prefer to add this way or if you'd prefer to carry numbers like we would show. Well, this is kind of the basic format for it. But if you want to, you can just add them directly. So here's what I mean. I do 9 times 1 here first. So 9 times 1 is 9. That's only one group of 9, or 9 groups of 1. That's 9. So that's fine. So that's the ones. Now what I'm going to do is I'm going to put the tens in a whole different row right here, knowing that I'm just going to add whatever these products are. So I'd say, okay, 9 times 5. Now 9 times 5 is 45, right? But that's 45 tens, which really makes this, like I got 45 right here, but that's from the tens, which means I need a 0 in the ones place value. And then I put the hundreds from the multiplication into its own separate row as well, which is 9 times 6. So I am in the hundreds place value here. 9 times 6 is 54. And then again, all those other place values become zeros. So what we can do from here is just add. And it sets up very nicely because we're looking at each place value separately. So 9 plus 0 is 9. 5 plus 0 is 5. 4 plus 4 is 8. And then the 5 in green there just stays. So it looks like our final product of 651 and 9 is 5,859. Now, along those lines, I'm going to show you, it's a little trick. Whether you memorize the trick isn't important, because if it helps you, you probably will memorize it. If you hate it, then you're not going to memorize it, right? But there's a rule of nines when we multiply, at least with some of the lower values, just the single-digit values, right? So it's the rule of nines. This wasn't in the notes. I forgot about it. So what you can do is you can look at your fingers, right? If you put all 10 fingers up, you'd end up with something like this. I put the thumb on the wrong side. I hope that doesn't matter. We got 2 left hands, it looks like. But in any case, rule of nines, all right? So here's what you would do. You'd say you got, let's start with 1 times 9, okay? Well, here's what you're going to do. Is you're gonna go either direction as far as you want to go, but you should start on either one of the ends, and you'd say, I'm going to put this finger down, and what do we get? 9, right? See how that's 9 right there? I got 9 fingers up. 1 times 9. That's very nice. Okay, well, let's go back. Let's put that finger up again. And let's say that we did 2 times 9, and we wanted to figure out that product. Well, we can use the rule of nines with our fingers. So I'd look at my second finger, which is this one, and then I would put it down. Right? So it's kind of split right here. Is what's happened. And what do you get? You get 1. That's tens. And then how many fingers do you have up over here? 8, right? So you see, I guess I got my thumb up. Maybe I put this thumb on the wrong side. If I'm looking at my palms anyways. So yeah, this one goes down, and I got 1 and 8, which is 18. I know this is kind of hard to explain when I'm using a diagram like this, but let's go back and see if it's going to work with all the values, all right? So if I go back, and again, I'm looking at my palms, which is why the thumbs are out. But if I put down my third finger, this one right here, then what do I got? Well, I've got the 2 and 7 more, right? 2 and 7. So that'd be 3 times 9. What the heck? 3 times 9. So I got the 2 fingers up there on my far left, and then the 7 fingers up on my right, which makes 27. And this will work for any multiplication all the way up to 10. So you'd say, let's go to the next one. So I got this one up again, but now I'm going to put this one down. Right? So that would be 4 times 9, which is 3, so that'd be 30, and 6, 36. And I'm not going to do all of them, but I'm going to skip all the way to 8 at least, just so you can see it would work, even if you have the table in front of you. So if I multiplied by 8, I'd go over here, I'd say, okay, where's my 8th finger? 1, 2, 3, 4, 5, 6, 7, 8. So that's the finger I'm going to put down. This one right here. That's the 8th finger. And then what do I got? So as far to the left, that's the tens. And I got 1, 2, 3, 4, 5, 6, 7 fingers up, so that's 70. And then these 2 ones, 72. So 8 times 9 is 72. Now, I hope you find that a little nifty, because it's pretty cool. But if you don't, and you don't want to use it, you're like, man, I really hated what you just did right there, then I apologize. But some people find some usefulness in it. In fact, from time to time, when multiplying with some of these lower values with 9, I know I can do that with my fingers, which are readily available, as it turns out. And so I may do it more often than you'd like, but it's still a good trick. So I'm multiplying by base 10s. So if you multiply by base 10s, then remember, you're just tacking on zeros at the end. from wherever you multiply, okay? So remember, you're just going to count any non-zero digits. I'm sorry, you're going to find all your non-zero digits, and then anything to the right of those non-zero digits, you're going to set those aside, and those are going to be part of the product. So you're going to tack those onto the product, but then you're able to multiply smaller numbers, which hopefully would make things a lot simpler. At least there would be less writing involved. But once again, if there's zeros between non-zero numbers, we do not exclude those. We don't set those ones aside. So in these two examples, I'd be looking at any non-zeros number to the right of, I'd be looking at any zero numbers to the right of non-zero numbers, which is just these zeros right here. And there's 1, 2, 3, 4, 5 zeros. Now this does simplify the problem then into 21 times 1. And that's a much easier problem to do because anything times 1 is itself 21. But then, and this is where it becomes crucial because this happens often enough on a test or a quiz where students forget to tack on the zeros right. And it's not like they did it wrong, it's just that they forgot to tack it on. So I had 5 zeros there, so that's 1, 2, 3, 4, 5. Looks like that's 2,100,000 right there. That would be the product of 21 and 100,000. So we'll do the same thing for this problem, but we have zeros to the right of non-zero numbers in both of the factors. So we got 1, 2, 3, 4 from the 120,000, and also 2 more zeros from the 600. Which again, this is nice because then it changes the problem into simply 6 times 12. So 6 times 12, you may need to stack this if you'd like. You're welcome to do that if you need to. I do 6 times 12, so I do 6 times the 2 here in the ones place value. That would be 12. And then I do 1 times 6, but that's really 10 times 6, which would then be 60. And then you can add those to get 72. Now, if you memorized your multiplication facts, like we would like you to, up to 12, you'd know that pretty quick. But if you need to show the work for it, it's fine. But now that we've done that, we need to tack all the zeros that we weren't considering onto this product. I apologize. That may have been kind of confusing with, or mistaken for cross multiplication. Some of you, and this may be more appropriate for some of you, and it would be fine if you did it, is to write it more like this. And this is what a lot of people do, is they prefer to see the larger of the two numbers as the first factor. And remember, we can switch these around, right? It's not going to change the product. So if you saw this, then you'd say, okay, well, and it is going to be the same thing, but it'd be 6 times 2, it's still 12. And then you do the 6 times the 1 there. Just by place value, multiplication by place value and stacking. Yeah, that's still going to be 60 there. And yeah, when you add those, same product, 72. So now that we have that, 72, yeah, we just got to look at how many zeros we need to tack back on. 1, 2, 3, 4, 5, 6 total. 1, 2, 3, 4, 5, 6. So it looks like the product here becomes 72 million. We're going to need that multiplication by 10 stuff if we're going to multiply a certain way. Now, when stacking, if you take the shortcut, it's not a big deal, or you wouldn't really have to worry about the zero thing. But if you separate these into their expanded form, which you can do, again, it's not required that you do it one way or the other, but I mean, show with the expanding first, all right? So for this one, we got 67 times 21. So that's 67 times right there, times 21. But I'm going to split this up. Now, when I say split it up, what I really mean is that I'm going to split the second factor up, which in this case is 21. So 21 then becomes 20 and 1. And we're going to multiply these two by 67 because that's really what we end up doing in the end anyways, no matter how you like to do it. So I'm just doing it in separate problems, which may help us to organize this in our brains. If you prefer to see these as separate problems, feel free to do it. If you prefer to take the more shorthand method, then that's fine as well. It's going to be the same thing. So right here, I got multiply by 1. This is nice because anything times 1 is itself. So I'd say 1 times 7 is 7, and 1 times 60, that's 60, but combined with the 7 is 67. Now over here to the left, I'm multiplying 67 by 20, right? But what I can do is I can say, since I've got a 0 right here, I'm just going to tack a 0 onto my product. Okay, which really means that this simplifies into, I guess I need a little bit more space there, but it really becomes 67 times 2. So then I would say I'm going to multiply starting with the ones place value. That's 2 times 7, that's 14. You need to carry that 1 there, however you carry it, and you can just write 14 if you'd like. Maybe I should give myself more space. 67 times 2. So 2 times 7, that's 14 there. And then I'd do 2 times 60, which would be 12, but that's in the tens place value, so I'd have to tack on that 0. And then we would add these for the final product on this. 4 plus 0 is 4, 1 plus 2 is 3, and then we have the 100. So this product is 134, but we can't forget about the 0 in purple there that I had to start with. Well, to find the final product of 67 and 21, we just need to add the two values together because, remember, we split it up in the beginning, right, between 20 and 1. So it's really 1,340 plus the 67. And this would be the final product. So 0 plus 7 is 7. 4 plus 6 is 10. Carry the 1. 1 plus 3 is 4. And then we'll drop the 1 there to make 1,407. This other one, 52 times 761, I'm going to do with kind of the shorthand method, which really is just what we just barely did by separating the two numbers. But again, it's just a little bit shorter in terms of how much work is shown. Now, to make this one a little bit easier, you could do, just like we've shown, you could do 52 times 761. And you'd get the same product. But what I'm going to do instead is I'm going to flip the two numbers because I think it's generally easier to see this multiplication stuff if you have the bigger number, the bigger of the two factors above. So I'm going to write this as 761 times 52, like this. Now, again, this is shorthand, which means any carrying that takes place is going to have to take place above the place values, okay? But when I get into the tens place value, and we still are stacking the numbers, which we had to add anyways, so whether you like it or not, that's going to have to happen one way or the other. So I'm going to start with the ones place value, the 2 specifically. I'm going to multiply it by all of the place values in 761, starting with the ones place value. So that's 2 times 1 is 2. Now, again, that's 2 times 60, but I'm just in the tens place value, so whatever I get will stay in the tens place value. Now, that would be 12. But again, since I have the 1 in the hundreds place value in green there, I'm just going to carry it above the 7. Okay, now that 1 that I have in green above the 7 is not being multiplied at all. It's going to be added to the product because it came from a different place value. So we got the 2 times the 7 there, which is 14. But from that 14, I need to add the 1 above the 7, which then makes 14 plus 1 is 15. So just by taking 2 and multiplying it by 761, I get 1,522. Now that may seem like a big number, but we're not finished yet, right? We have to multiply from the tens place value, and when I multiply it by the tens place value, I start in the tens place value, which means that there's not really anything in the ones place value here. I've seen some students where they don't actually use a 0 here to hold the ones place value, but I like to have it there just so I know that I'm dealing with the tens place value. And yeah, we start with the tens, the 5, right? The 5 in the tens place value, and I'm going to multiply it by all 3 values of 761. So I would start with the ones place value. That tells me how many tens are produced. 5 times 1 that'd be 5 tens there. And then we just move to the left at that point. So that's 5 times 6, Now that's 30, but the 3 now in the thousands place value has to be carried over above the hundreds place value. So that's because I've got 10 times hundreds, which is now the thousands. So I would say I got the 30 from the 5 times 6. I carried the 3, and then I've got 7 times 5, which is 35. But I still need to add the 3 to the 35, which is just going to change that just a little bit. 5 plus the 3 there in the ones, if you will, is the 8. But again, that's a big number, 38,050, but I still need to add it to what I have as a result from my ones place value, which is 1,522. So let's go ahead and add these. Again, starting in the ones place value, 2 plus 0 is 2. And now the tens place value, 2 plus 5 is 7. And the hundreds place value, 5 plus 0 is 5. And now the thousands place value, 1 plus 8 is 9. And then the 3 just drops as 30,000. So our final product of 52 and 761 is 39,572. So we do have multiplying with rounding. So, they may ask you to round a different place value. Sometimes it's front-end rounding, or sometimes it's a specific place value. So we're going to round to the highest place value, whichever one it tells us. Again, that may be different between factors if it's front-end rounding. And then just multiply the numbers that remain, which is why the multiplication with the base tens is going to be important, because we look at the zeros and we just kind of remove them and know that they're going to be attached to whatever the product is. So this first one, it's 687 times 108 using front-end rounding. So I would go to the front end of both numbers, I would round, and then whatever I get out of that, that's what I'm going to be multiplying together. So I would start with the 687, so I start with the 6 in the hundreds place value. In the tens place value is an 8, which is 5 or more, which means I need to add 1 to the hundreds place value. So 687 front-end rounded becomes 700. And then I multiply this by whatever 108 rounded is. So I go to the front end of 108. So I see the 1. In the hundreds place value, to the right of that is a 0, which is less than 5. So the 1 just drops as a 1. And then the other two place values are zeros. So really, we got 700 times 100. But I'm going to take the zeros, 1, 2, 3, 4 of them, and I know that I'm just going to tack those on to the product. Now, whether you do it now or later doesn't matter. I'm going to tack them on now just to show that you can. We have 4 zeros, and that simplifies the problem then into really 7 times 1. And 7 times 1 is 7, because anything multiplied by 1 is itself. So this ends up being 70,000. After the front end rounding, of course. So this next one wants front-end rounding, but we can see that we're going to be rounding to different place values, which is fine. That's okay. But the nice thing about front-end rounding is we're just tacking on zeros to whatever the product is. So right here, I'm going to start with the 6,061. And again, it doesn't show the multiplication between the 6,061 and 52. It doesn't have to, but we don't see the operation, so we just know that it's multiplication. So I go immediately to the right of the 6 in the thousands place. That's in the hundreds place is 0, which means the 6 is just going to drop as a 6. All three of these other place values become zeros. Now let's front end round 52. So that's a 5 in the tens place value. To the right is a 2 in the ones. The 2 means that it's less than 5. So the 5 in the tens place value just drops as a 5. And then the ones place value is a 0. So once again, we go through the product here, the two factors, and in the product will be however many zeros there are being multiplied. And we got 3 zeros and 1, which is going to produce 4 zeros again. But by doing so, we've reduced the problem then into 6 times 5, which is pretty good multiplication. If you can count by 5s, you do it 6 times, or use the multiplication table, or just the facts that you have memorized. 6 times 5 is 30, which we tack on to the zeros now, which makes that 300,000. So that is the product of 6,061 and 52 using front-end rounding.